before we start writing our first smart contract, you need to have Stellar CLI installed, among other things. So here's what you do next. Simply click here, and it's going to lead you to the setup guide. As you know by now, Stellar smart contracts are written in Rust, so make sure you have Rust installed. So install it according to the operating system that you're using. If you're using Mac OS or Linux, simply use this command on your terminal. If you're using Windows, I recommend that you have WSL installed so that you'll be able to simply write command on your Ubuntu for Windows terminal like I have here. So once you have that, you can check the version. To check the version, you simply use this command. Add it here, and my version is Rust version 1.93.1. And next, install the target, because you need a target for which your smart contract will be compiled. So use this command on your terminal, and once you have that sorted, you configure your editor. I recommend Visual Studio Code because you can install a lot of there's a lot of extensions that you can use, like the Rust Analyzer for Rust language support and Code LLDB for step-through debugging. Once you have done all that, you can then install Stellar CLI. So the Stellar CLI can execute smart contracts on FutureNet, testnet, mainnet, as well as in a local sandbox. So the latest release is a 25.1.0, and to install it you can use, if you're using Mac OS or Linux, you use the following command. You can install it using a script, or you can use this command if you're using Homebrew, or you can install it using Cargo from the source. So simply go to these docs and follow through. It's very simple to follow. So once you have that sorted, now you can write your first smart contract. To create a project, you simply have to use this command, Stellar contract init, and the name of your project in this case is Soroban Hello World. And this is the project structure. In the root of your folder, the folder of your project, you'll see cargo.lock, cargo.2ml, readme.md, and you'll see a contracts folder. Under the contracts folder, there's going to be a Hello World folder, and under that folder, there's a cargo.2ml makefile and a source folder. Under that source folder, you'll see two Rust files, the lib.rs, which is where you're going to write your smart contract, and the test.rs, which is where you're going to write your test. So I already did that. I created my project using this command here, and I'm now in the folder, and I use code space dot to open it on Visual Studio Code. Once you create a project, it comes with this Hello World, this simple Hello World project by default. I'm going to explain it step by step. The first line says no underscore std. This means that the contract does not use Rust standard library. And the reason for this is that smart contracts run inside a restricted WebAssembly execution environment. They cannot access the operating system files or external libraries. Instead, they rely on the Soroban SDK, which provide all the tools needed to interact with the blockchain. That is why we import Soroban SDK here. Next, we import several important components. We have contract contract implementation, vector, env, string, and vector. Let me explain this quickly. The contract macro tells Soroban that this tract represents a smart contract. The contract implementation macro marks functions that can be called externally on the blockchain, and the env type represents the execution environment of the contract. Through it, the contract can interact with storage, ledger data, and other blockchain features. The string and vector are Soroban compatible versions of strings and vectors. This is not coming from Rust standard library. This is directly from Soroban SDK. And we also have the vec macro, which help us create vectors inside Soroban environment. Next, we define a contract. Under this, we have a struct called contract, a public struct contract. You might notice that the struct is empty, but that's because the logic of the contract lives in the implementation block. And this is what we're seeing next. Every function in this block becomes a callable function on the blockchain. Think of these functions as the public API of the smart contract. And here we have the function called hello. It takes two inputs. First we have env, and we have a string called to. So this string is the string that the user passes when calling the contract. The function returns a vector of string. And now let's look at what it's returning. We have a vector of two elements that contains two elements. The first element is a string called hello, and the second element is 2, which is the value that the user passes in. For example, if the user passes a value called David, it will return a vector of strings hello David. So this contract is simply returning a greeting. While this example is very simple, it demonstrates several important concepts. First, how functions receive input. Second, how contract return value. And third, how Soroban types are used. Now, before deploying a smart contract, we always test it locally. Soroban provides a built-in testing framework that allows us to simulate the blockchain environment, and I'm going to show you next.